So we're jumping to number 17 on the practice final. This one is a logarithm. It says express log base 5 of 625 to the fourth as a product. Well, product means multiplication, right? And we need to think of the different properties of logarithms to help us do this problem. And this is from our green book. I hope you guys remember this, the properties of logarithms. There's the product property, which is saying that if you have log of something times something, you could split the log and make it log of the first something plus that same log of the second something. Or you could go backwards to condense. If you have a plus sign with the same exact logarithms, you could condense them to be one single logarithm with the two terms being multiplied together. Then you have the quotient property, which is saying that if you have log of something divided by something, you could split that single log into two logs and do log of the top one minus log of the bottom one. So you could expand it, or you could have this one and go backwards and condense it. And the one we're using on this particular problem is the power property. And that's where you have a power, you could put it out in the front as multiplication, or you could take that multiplication and raise it up to be a power. It depends what they're asking you to do to condense or expand. So in this case, we're going to take the power of 4 and we're going to bring it down. We're going to take the power of 4 and bring it down right in front of the logarithm. So we're going to have 4 times log base 5 of 625. So it says express it as a product. Well, right here we are expressing it as a product. Product means multiplied. So we really do have 4 times log base 5 of 625. And you're probably thinking, wait a minute, why isn't that answer here? That's because the log base 5 of 625, you could actually simplify that. Remember how logarithms work, guys. The base 5, that's like saying 5 to what power equals that number 625. And that actually works out very nicely. 5 to the first power is 5, to the second is 25, to the third is 125, to the fourth power. 5 times 125 is actually 625. So when I think of log base 5 of 625, I really have the answer 4 right there. How do I know that? Because of this thought process, that 5 to the fourth power is 625. So I really have this 4 that's out in the front, 4 times 4, so my final answer is 16. So if I were to express this original logarithm as a product, I'd have to multiply 4 times 4, which means my final answer is 16. And that's how we get A for number 17. And if you guys understand that, you should be able to practice with number 18, I believe, because it's the same exact math. It's just different numbers. Cool. Number 19, you want to evaluate that logarithm. And it says, if necessary, round your answer to the nearest tenth. Now that logarithm, you're going to have to use the change of base formula. Now your calculators don't do base 9, right? They either do base 10 or base E, which is the ln button. So we first need to know what the change of base formula is. This is from our textbook. The change of base formula says that when you have log base anything, in this case base C, of anything, in this case A, you could change the base to whatever base you want. You could put log base B, whatever base you want, of the bigger number up on top and the smaller number on the bottom. Okay? So, like I said, the calculator only does base 10, which is a common log, or base E. So you either want to change this to base 10 or base E. Okay, so how's that going to work out? Let's go back to our problem here. We're going to take log base 9 of 243, and you could use common log up on top and common log on the bottom. And we put the bigger number up on top, 243. I put the smaller number 9 on the bottom, and you type that into your calculator and you should get your answer. So if we take a look at a calculator, you're going to type in common log, and the common log button is right here. That's base 10. Common log of 243, 243. And you're going to end up closing parentheses. So on your screen, when you hit the common log button, it's going to open up some parentheses. You type in 243, close parentheses, and then hit divided by, and then common log again, and it's going to open up some parentheses again. That's going to be a 9, close parentheses, hit equal, and you'll get the answer 2.5. Notice that on this first one, I used the common log on the change of base formula, or if you want, you could use the log base E, which is a LN button. It's still going to give you the same answer, 2.5 and 2.5. All right, so it's really just a question of knowing the change of base formula, and then being able to use the calculator. So the answer is 2.5. So hopefully you guys could try out number 20 and see if you could get the right answer, because it's exactly like number 19. Let's move on to number 21. It says use inverse operations to write the inverse of the function f of x equals x divided by 2 minus 2. So remember, f of x is really like a y, okay? And what we want to do here is switch x and y. Remember, to find the inverse, you have to switch x and y and solve for y. So if you are having trouble remembering that stuff, jot it down. Switch x and y and solve for y. So right here I've switched x and y. Now all I need to do is solve for y. So I need to get y by itself on one side of the equal sign. So I want to get rid of the minus 2 by adding 2 to both sides, plus 2 plus 2. So my new equation will read x plus 2 equals y divided by 2. And for my final step on getting y by itself, on solving for y, I'd have to multiply both sides by 2. To get rid of the divided by 2, I multiply by 2. That way it cancels out. And of course, what you do to one side, you do to the other side. And I'm talking about the entire side. I'm talking about everything. Multiply it by 2. So you're going to have to actually distribute that 2. So you will get 2x plus 4 equals y as your final answer. Now, if I look through the multiple choices, I don't see a 2x plus 4, because apparently they just stopped right here. They didn't actually distribute the 2 into both of them. So the correct answer is C. And of course, if you understand number 21, you should be able to do 22 and get the correct answer. And of course, check your answers either on the board right here in class or on the post on Edmodo that has the solutions on there also. So we're going to skip number 22. You can try that on your own. Let's move on to number 23. Simplifying ln of e to the negative 7x. When we say simplify, we're saying do any math possible. Okay? So when you see ln of e, those are actual inverse operations of each other. They undo themselves, right? It's like having a square root squared. The square root and the square will undo itself. If you want to see and understand this better, ln is really log base e, and then you have of e, right? And it's to the negative 7x power, to the negative 7x power. So what happens with the log base e of e, that totally cancels out, and the negative 7x comes down, and believe it or not, that's your answer. That easy. It's like free points on the final. Okay, so if you understand number 23, you should be able to do number 24. And let's move on to number 25. 25 is up here. Give it a second. So number 25 is multiplying two fractions, and right there it's all about canceling whatever's the same on top with whatever's the same on the bottom. So we could start canceling out the coefficients, like the 4 and the 8. 8 divided by 4 is 2, and you'd write that 2 up on top. The 3 and the 9, 9 divided by 3 is 3, and you write that 3 up on top. Let's zoom in a little so we could check out the x's here. Let's cancel out x's. Are there any x's on the bottom? No x's on the bottom, so I can't cancel out any x's. So we're going to move on to the y's. We could cancel out y's. The question is, you could do this, you could do a couple of steps at once. How many y's do we really have up on top? We have a y squared and a y squared. That's really 4 y's up on top, and there's 4 y's on the bottom. So all those two and those two cancel out with those 4. So there are no more y's. What do we have left over? We have some z's, and we could cancel out z's because we have 4 z's on the bottom and 6 z's up on top. So all 4 of them cancel out with 4 of them, and there's going to be 2 left over up on top. So let's, I know it looks like a giant mess. Let's see what we have so far. We have this 2 right here with an x to the 4th. Let me write that down. 2x to the 4th. There's nothing underneath it, so I could put over 1, but that's pointless. I'm just going to leave it 2x to the 4th. And I need to multiply it. I need to multiply it with whatever's left over on this guy. There's a 3 and an x and a z squared. So that's 3x and a z squared. So I need to multiply 2x to the 4th times 3x z squared. So 2 times 3 is 6. X to the 4th times x to the 1 is x to the 5th. And the z squared just comes down. So there's your final answer, which is A. Ta-da. So if you understand number 25, you should be able to do number 26 because it's the same exact problem. It didn't change values. I apologize. Number 27. We want to solve this equation. Now, when you see the word solve, you need to remember that that means get x by itself on one side. All right? Now, we have a fraction. It looks nasty. There's a lot of terms right there. There's a quadratic trinomial up on top, a binomial on the bottom. So what should pop up in your head right now? Factoring, right? Factor to see if you could cancel out anything. So on the top, I'm going to try to change that trinomial to a binomial with the x in there on both of them. So what times what is negative 12 that if you add together is negative 4? Negative 6 and positive 2. All right. And on the bottom, we do have an x minus 6. And this is an equation, so it is equal to 8. Now, the awesome part is that once we factored, we're able to cancel the x minus 6 with the x minus 6. So we really have the equation x plus 2 is equal to 8, which we all know if you solve, the answer is x equals 6, yeah? Yeah. Now, if you circle that answer, you're going to get it wrong. Now, you're probably thinking, what? The answer is 6. No, it's not. It's not, right? Now, you're thinking, yeah, it is. It says right here, answer 6. But remember, you need to take a moment and check. If you plug in 6 into your x's, it doesn't matter what you get on top because on the bottom, you're going to have 6 take away 6, which makes it undefined, which means that 6 is an extraneous solution. So what's our real answer here? B, no solution. That's the real answer. So it's definitely not C. Scratch that out. The correct answer is B, no solution.